Stoichiometry. Oxidation number. A molecule of an atom would have a charge if electrons were completely transferred. Oxidation numbers are also called oxidation states assigned to the atom according to a set of rules. The rules for assigning oxidation numbers are: first one, free elements not combined with other elements have an oxidation number of 0. For example, potassium, plumber, hydrogen molecule, oxygen molecule, phosphorus. These three are molecules, but they are elements because they are not combined with other different elements, and their oxidation number are 0. The oxidation number of hydrogen is positive 1, except when it is bonded to metals in binary compounds. Binary compounds means the compounds that consist of two elements only. So if any hydrogen bind to another element makes the molecule have two elements in total, it is binary compound. In these cases, the oxidation number of hydrogen is negative 1. If it's not binary compounds, the hydrogen oxidation number is positive 1. The oxidation number of group 1 metals are always positive 1, group 2 metals are always positive 2, and fluorine is always negative 1. In a binary ionic compound, the oxidation number of the element is the same as the charge of the ion. So Fe charge positive 2, Cl charge negative 1. The oxidation number for each individual is the charge of the ion. Next, the sum of the oxidation numbers of all the atoms in a molecule or ion is equal to the charge on the molecule or ion. In the NH4 plus ion, the whole charge for NH4 is positive 1. Overall charge for the whole ion is positive 1. But individual atom, N atom is negative 3, H equal to positive 1. So negative 3 plus 4 times positive 1, because we have 4 hydrogen, equal to the overall charge. NH4 overall charge positive 1, so equal to overall charge. The oxidation number of oxygen is usually negative 2, except in H2O2 and O2 In both, the oxidation number of oxygen equal negative 1. Other than this, the oxidation number of oxygen is negative 2. Determine the oxidation numbers of all elements in the following compounds. For A, HCO3 minus, so the overall charge of this ion is negative 1. We know the overall charge is negative 1. And we know the oxidation number of oxygen, negative 2. It's stated in the rule. The oxygen number of hydrogen stated in the rule is positive 1. Now, we need to determine the oxidation number of carbon. So you substitute the value of oxidation number for oxygen and hydrogen to identify the oxidation number of carbon. 3 times negative 2, because we have 3 oxygen, the oxidation number negative 2, so 3 times negative 2, plus 1 times 1, because you only have 1 hydrogen, plus the carbon equal to negative 1. This is negative 1, the overall charge. So if you solve this, you'll get carbon equal to positive 4. This is the oxidation number for carbon. B, IF7. The oxidation number of fluorine is always negative 1. So we need to identify the oxidation number of iodine. 7 times negative 1 because we have 7 fluorine atoms plus I oxidation number, we don't know the oxidation number of I, equal to 0 because this is a neutral molecule, no charge. So when the molecule is no charge, the compound is no charge, it must be equal to 0. So you get the oxidation number of I. When you solve this equation, you will get positive 7. This is the oxidation number for iodine. Stoichiometry, the numerical relationship between chemical quantities in a balanced chemical equation. Stoichiometry shows numerical relationship. We have chemical quantities in a balanced chemical equation. It allows us to predict the amounts of product formed in a chemical reaction and how much of the reactant necessary to form a given product. Chemical equation is a statement that uses chemical formulas to express the identities and quantities of the substances involved in a chemical or physical change. For example, C3H8 plus 5 oxygen. The products are, these two are reactants, the products are 3 carbon dioxide plus 4 water. This is an example of chemical equation. This involves in a chemical or physical change. The reactants must appear on the left, means before the arrow, and the products must appear on the right, after the arrow. The arrow joining them indicates the direction of the reaction. So from C3H8 reacts with oxygen, producing carbon dioxide and water. There are two methods that can be used to balance the chemical equation: inspection method and algebraic method. Look at the inspection method first. Step 1, you have to write the unbalanced equation using correct chemical formulas for all substances. These are the unbalanced equations. Step number 2, find coefficient to balance the equation. Start with the most complex substance and deal with one element at a time. So you focus on one element at a time. So let's start with C8H18. This is the most complex compared to oxygen, carbon dioxide and water. On the left side, we have 8 carbon, and on the right side, you have 1 carbon only. So we put 8 carbon at the carbon dioxide, put 8 here and 1, so it's balanced. 8 carbon on the left, 8 carbon on the right. And then after you balance 4 carbon, continue with the hydrogen, because we focus on the complex molecule first, C8H18. Focus on this first, so continue with hydrogen. We have 18 hydrogen on the left side in total. We have 18 because 18 times 1, 18. So you must have 18 hydrogen on the right side. There's no hydrogen here, but there's hydrogen here. So H2 times 9 because we need 18. So balance 18 on the left, 18 hydrogen on the right. Now check the oxygen. On the oxygen, we have 2 oxygen on the left, but 16 plus 9 oxygen on the right. So we need 25 oxygen on the left because you have 25 in total oxygen on the right. You need 25 oxygen on the left. So 25 over 2, so you cross out this number 2 and this number 2, so you have 25 oxygen in total on the left and 25 oxygen in total on the right side. Balance. So when you adjust your coefficient, if you don't want to leave it in a fraction state, you can times by 2 for all of the compounds. So times by 2, times by 2, times by 2, times by 2, you get 2 C8H18, 25 oxygen, 16 carbon dioxide plus 18 water. Make sure to specify the states of matter: C8H18 liquid, oxygen gas, carbon dioxide gas, water vapor here. Write the unbalanced equation and insert symbolic coefficient to the substance. This is the first step for algebraic method. So we have Al react with oxygen to produce Al2O3. We don't know the coefficient of this. We don't use the inspection. We are using algebraic method now. So you put the unknown or insert symbolic coefficient. Unknowns A, unknowns B, unknown C. Still unbalanced, so because you have 1 Al on the left, 2 Al on the right, 2 oxygen on the left, 3 oxygen on the right, so it's unbalanced. Next step, you assume A equal to 1, solve for B and C, because if you assume A equal to 1, we know the value of A already, 1. We can solve B and C. We know that A equal to C because 1 Al, here 2 Al, so that's why A equal to C. When you assume A equal to 1, so C equal to half. C equal to half. Or 2B equal 3C. This is O for oxygen, B 2B equal 3C. 2B equal 3C. We have the value of C, half, so 3C, and then you can solve the value of B. So this is the value of B, 3/4. Adjust the values of coefficient A, B, and C to obtain the whole number. So 1, A equal to 1, B equal 3/4, C equal half, and then you need to obtain whole number times by 4, so you get 4 Al plus 3 oxygen. The product is 2 Al2O3.